Welcome back. We're on Unit 4, Lesson 8, where we're going further into other ways of solving equations. So we did some stuff where we could factor. But if you remember when I first went over factoring, when we first did it as a class, we went over and said, like, factoring doesn't work all the time. I promise that on the test it will work, that you'll always be able to use AC method if there's 3 terms, but it is not always true. Also, factoring has that other barrier that you must always set it equal to 0 first. You must simplify it, but we want to find the most efficient way possible. So here is one way. Let's look at this equation again. If you recall, when we solved this, we factored it x minus 4, x plus 4 equals 0 to get x equals negative 4 and positive 4. Some of us might see, oh, why can't I just solve it algebraically? X squared equals 16 by adding 16 to both sides. And to undo a square, what we can do is square root. Just like how subtraction, the opposite addition, and multiplication, 2x equals 5, is division. For exponents, squaring and square rooting are opposites, they are inverses. So if I square root this, the square root of 16, we should know, is 4. We know intuitively, you might have practiced square roots. Sometimes we kind of want to memorize squares. We did this back in Unit 1. But the square root of 16 is 4 because 4 squared is 16. However, that misses one of my solutions. 4, yeah, that's one of my solutions, but I'm missing negative 4. So something I want to highlight right now is that whenever you square root a value, whenever you square root a number, you want to make sure you have a positive and negative. So we have a plus and minus 4. That's a new symbol. So whenever you square root, include positive and negative, plus minus. So my answer is plus minus 4, and that's a valid way of writing answer. Writing it spread out like this also works. But we have positive and negative 4 as my answers. This is called extracting the root. We want to solve algebraically by getting rid of the square, by finding the root of my value. Let's look even further. Let's see that this application works beyond this. Because, for example, if I have this expression right here, 2x plus 1 equals 4, solving algebraically, what you can do, you can distribute the 2, multiply it, get 2x plus 2 equals 4. But that is an extra step. We want to be efficient with our time, efficient with the steps we take. So we learned that we could divide both sides by 2. X plus 1 equals 2. To get x equals 1. This works. So in the same way, square rooting, we see that, oh, it's x squared, but we want to, like, whenever we have anything squared with our variable, we can square root. Let's look over when we could do it and how we could do it. So x plus 2 squared equals 16. First step, I want to square root both sides. To get me x plus 2 equals plus and minus 4. Next, I want to subtract 2. But how do I subtract 2 if 4 is both positive and negative? Because this is actually 2 different numbers. This is a neater way of writing it, but it's actually 2 different numbers. Once you get to this point, and you can do an operation onto your plus minus, you want to split it up. So I'm going to split it. X plus 2 equals positive 4, and x plus 2 equals negative 4. To get x equals 2, x equals negative 6 as my answers. So even though we have the plus minus, that's not your final solution. It might not be your final solution. It could be, but it may not be as well. So you want to make sure if you can do more math to it, you want to apply this math. Something I want to also highlight is we might have seen this and be like, why can't I subtract 2 first before getting the square? Let's look at another example and let's go over, reinforce what we learned back in algebra. 5k plus 1 squared equals 5. I have a 5, a plus 1, and a square all happening to this k. One thing we could do is this acronym. I'll write it out first and we'll go over the acronym. It is to solve algebraic equations. We do opposite order, opposite operation. To give us the acronym OOO. So we have 4 O's. It's not the best acronym, but it is a fun one that you will memorize. This is saying that my opposite operation first, the opposite order. This is the order of operations. We have PEMDAS. When you have PEMDAS, this k, we look at what happens first, my parentheses. So first off, I add 1. Next up, I do my exponent, I square. And finally, I multiply. After that is addition, subtraction, but the plus 1 happens first because it's parentheses. So I write out my order operations, and what I do to get rid of this, to undo it, is opposite order, opposite operation. So now going bottom up, I want to do the opposite. So instead of multiplying by 5, I first get rid of this 5 by dividing both sides by 5. And then the square is next. So I square root both sides. Square root. Don't forget your plus or minus. So k plus 1 equals plus or minus 1. And lastly, I subtract 1. But once again, we see that we can't do it. Another way of writing it is k equals plus or minus 1 minus 1. And I split it from here. Equals positive 1 minus 1. So k equals 0. K equals negative 1 minus 1 to get k equals negative 2. K equals 0, negative 2. So opposite order, opposite operation. Another way that I like to express it is to work outside in. Because a lot of times with PEMDAS, it's kind of inside out. Whatever's closest, the parentheses happens first. So inside is the plus 1, then the square, then the times 5. So outside in will be 5, the square, plus 1. Outside in is a bit more confusing because to distinguish between multiplication and exponents, they're both right outside the parentheses. So it's hard to see which one to do. So if you want to do PEMDAS, opposite order, opposite operation, if you want to list it all out, I highly recommend it. At least do it for the first couple of times so you get the hang of things. Because all this topic is solving algebraically with this new rule. To undo a square, we square root and have a plus minus. Let's do one more. And let's go over some rules that will help with this. Actually, let's do 2 more. So x minus 1/2 squared equals 1 over 4. I see that my order is I subtract 1/2, then I square. So I square first, then I get rid of 1/2. Square root, x minus 1/2 equals plus or minus. To square root a fraction, we want to look at the numerator. The square root of 1 is 1. The square root of 4 is 2. So plus or minus 1/2. Then we split it up. x minus 1/2 equals 1/2. X minus 1/2 equals negative 1/2. To get x equals 1, x equals 0. Now, the next one, we can see that we won't always have clean square roots. 13 minus 4z squared minus 12 equals 0. Quite a big step up, but I recommend you could pause this right now. You can solve it. We'll go through it together. Just follow the rules that we have. So first off, my first step is I'm multiplying by 4. Next, I'm adding 3 is like negative, so the 13 is in the way. Next up, I square. And finally, I have to subtract 12. To do work, I want to work backwards. So add 12. So 12 equals 13 minus 4z squared. I get rid of the square. So 13 minus 4z, the square root of 12 is not clean. Square root of 12. We can simplify this by root 12 simplifies into plus or minus 2 root 3. We always want to simplify if we can. Next up, the 13's in the way, so minus 13, negative 4z equals plus or minus 2 root 3 minus 13. Here is another rule that we care about for this course. Here, for this question, most of the time I'll ask you for exact form. For exact form, there's no way to add or subtract 13 from 2 root 3. So I can't combine these two, so it just stays. We can leave the plus or minus here, because I'm not doing any math to this. If for exact form, keep radicals, and 99% of the time, you can't do anything to it, so you keep the plus minus. So we keep it right here. And finally, get rid of 4 by dividing by negative 4. So z equals plus or minus 2 root 3 minus 13 over negative 4. That is my final answer because I can't subtract 13 from 2 or 3. There's nothing to reduce as a GCF from here. So this is the overall concept. And now let's look back at our problems to see what looks the same in all our problems. So I have over here 13 minus 4z squared minus 12. Very bizarre problem. Over here, x minus 1/2 squared equals 1/4. So unlike my previous lesson, we don't need it to equal 0. We can solve it no matter what. In fact, over here, we didn't have any equals 0 until our last question. But what we do see, what I want us to realize, is that there's only one variable. In this problem, there's only x. Once I factor, I have 2 x's, but up here, there's only 1 x. Over here, there's just 1 x. There's only 1 k. Here, technically speaking, there are 4 z's, but like reading it, there's only one variable. So understanding the context of what I'm saying, there's one variable. I'm not saying there's like one variable as in like it can't be multiplied by something, but there's only one variable as in there's only one letter written down. And that variable is being squared. One variable squared. So if you just have one variable that's being squared, whether externally or like it's right attached, like right here, as long as there's one variable squared, we want to use this method. You can still factor, possibly. Like over here, you could factor and solve. But here we have, it doesn't equal 0. I have fractions. It's hard to factor. might not even be able to factor. Over here, we have something bizarre. We have radicals in the answer, so that would mean that if I factor, I have radicals in my factoring, which seems impossible. I personally wouldn't be able to do it. So if you have one variable squared, look for this method. Try to extract the root. Hopefully this has been helpful. As always, if you have any questions, please let me know, and have a good night.